Hello, welcome back. Remember in the last lesson, I took you through a bit of history to show how to find the square root of 20 and showed you how by taking average of approximations you can arrive at a good result. Yeah? But then we said it's not always square root of some number. It could be a quadratic equation, it could be a cubic. So I took the equation x squared minus 4x plus 1. After committing a dumb error, I showed that it's between 3 and 4. I wrote the first iteration, if you remember, as x equal to square root of 4x minus 1, and then I showed you how the iterations converge. In other words, for the equation x squared minus 4x plus 1 equal to 0, the root in the interval 3 less than x less than 4, I took the equation x1 equal to, x2 equal to root of 4x1 minus 1, x3 equal to root of 4x2 minus 1, x4 equal to root of 4x3 minus 1, and I showed you, irrespective of what your x1 is, you can, the particular method gives you the root. Now in other words, remember I told you, you rewrite the equation in the form x equal to f of x. Always x equal to f of x. That means you are finding the root at the point of intersection of the line y equal to x and a curve. So I rewrote this again by taking 4x to the other side. So let's see if this graph works. This is the point that is between 3 and 4 only. So the graphs have to cut between 3 and 4. Okay. Suppose you put x as 3, 3 squared is 9, 9 plus 1, 10, 10 over 4 is 2.5, somewhere there. And suppose you put 3.2. What is 3.2 squared? I need to use my calculator as usual. Alright. 3.2 square plus 1 divided by 4 is 2.81. So at 3.2 it is 2.81. And then let's look at 3.4. 3.4 square plus 1 divided by 4 is 3.14. So this is 3.5, 3.14. And then suppose I take 3.6. 3.6 squared plus 1 equal to that divided by 4 is 3.49. At 3.6 it is 3.49. At 4 squared is 17, so 4 point something. This would be the graph of y equal to x squared plus 1 over 4. The actual root is there. They still intersect between 3 and 4. Now, this is where it becomes interesting. How did we do last time? I took a value of x. Let's say I take the value x. This has dried up. This has dried up. Let me try this. Let me extend this line because this is the line y equal to x. And this is the curve y equal to x squared plus 1 over 4. So that graph goes like that. And that graph goes like that. That's the line y equal to x. Suppose I take the first value x1, remember? Somewhere here. I need to put x1 here, correct? Because x2 is whatever the formula, put inside that. So, if I put x1 there, this would be f of x1. The y value here is the same as the y value there. That is also f of x1. And that will be x2. Now, if I assume that to be f of x2, draw a parallel, go there, that's x3. Now, the root is there. What is happening? Are you coming to the root? No, you're going away from the root. You're not coming to the root. So, in other words, you're not getting the root. That means you're running away from the root. So it's what is called a divergent iteration. That means it doesn't give you the root, you're running away from the root. Even here, suppose you assume that to be an approximation x1, that is f of x1, that will be x2, that is f of x2, that will be x3. What's happening? You're going away. So, to sum up, an iteration, a formula of iteration can either converge or diverge. Under what condition does it converge? Fortunately for you, condition for convergence, I don't think is there in any of your syllabi. Correct me if I am wrong. Maybe I have a sneaking suspicion that OCR might have. In any case, so if x equal to alpha is a root, so in other words, so therefore, to solve f of x equal to 0 using iteration. What is the first method? Number 1, locate root. Say a less than alpha less than x less than a plus 1. Alright? And the root is okay. Then number 2, rearrange f of x equal to 0 in the form x equal to phi of x. Number 3, rewrite as x n plus 1 equal to phi of x n. This way, look, x1, phi of x1 gives you x2, phi of x2 gives you x3, phi of x3 gives you another, and then number 4, start with a suitable x1. In other words, the root is between 3 and 4. You don't start with minus 22. You go for a root somewhere between 3 and 4, 3.5, if no value is given. And then x2 equal to phi of x1, x3 equal to phi of x2, x4 equal to phi of x3, etc. gives successive approximations to the root. But then I showed you in the same example, if you use one formula like root of 4x minus 1, you get the root. If you use the other formula, quarter of x squared plus 1, doesn't give the root. Then how do we know? Fortunately, if an iterative formula is to be used, they give you, because it's going to be very difficult to mark a paper if it is a use an iterative formula. Because we have got, let's say, 10,000 students, there will be about 70 to 75 different methods, different rearrangements. Then we can't have a scheme, or the examiner will go mad trying to figure out whether each one of them works. So generally they give you an iterative formula. Thank God for that. But sometimes they say, show that it converges. Then what you do is, you remember this phi? Phi dash of x modulus must be less than 1 in the interval. That's the condition for convergence. But you don't have to know it. I don't think it is necessary. I haven't taught it in edXL at all. Even though I did mention every time I taught edXL, it wasn't necessary. So therefore, but then, sir, but how will I know? The best way is, if it converges, then x2 minus x1 modulus, x3 minus x2 modulus, x4 minus x3 modulus, the differences should start decreasing. Then you got a root. Decreasing. If initially they might increase, but they start decreasing, it's not necessarily double one way. Look, it could be x2 and x1 2.1 and 2. Let's say the root is 2.3. Yeah, you might find the 2.32. You might take the first approximation to be 2.1. The next one you get 2.4. Then you get 2.21. Then you get 2.35. Then you go 2.29, 2.33. In other words, the difference, look, 2.4 and 2.1, the difference is 0.3. 2.35 and 2.21, the difference is 0.14. This is 0.04. So the differences should start reducing, then it converges. But if the difference starts increasing, then it will diverge. So show that it gives converges to the root. Then you show is do a number of iterations and show that the roots, the successive differences are becoming less. So you're approaching the root. Well, that is a brief explanation of iterations. In the next lesson, I don't think I have enough time to do in this lesson, because I don't want to go beyond 15 minutes or 16, 18 minutes, otherwise you'll go crazy. It's 11 minutes. Oops. So, when to stop? Let me just show when to stop. The rule is this. Use a calculator to find, let's say, x naught. Suppose I want, let's say, find root, I'm just taking an example, root to 3 decimal places. So your x naught, let's say, was 1.7. x1 was 1.824237, etc. Yeah? But then you say x1 equal to 1.824. Right? But to find x2, you use the calculator value of x1. Let's say you get x2 to be 1.837. I mean 8369426413, whatever it is. Use the whole value to find x4, x3. Maybe you may get 1.835. Sorry, 829. Then x4 is 1.832. x5 is 1.832. Then you stop when two values are identical to the accuracy required. So don't jump here, or don't say I'll do for x2, x3 only and stop. No, you keep on finding roots till two of them agree to the accuracy required. Like 1.832, 832. If two values are identical, you can stop there and say the root is 1.832, correct to 3 decimal places. And sometimes they say, show that your answer is correct to 3 decimal places. Many students say, look, I have shown this. No. The way you do it will be, find f of, remember the boundary values we did in GCE? 1.832 is 1.8315 less than or equal to 1.832 less than or equal to 1 less than 1.8325. So what you do is find f of 1.8315, find f of 1.8325, show change in sign. Of course, I'll take examples and show you in the next lesson. I'm just showing you here the theory so that I don't have to go over the theory. So, in conclusion, whenever you're asked to find a root using an iterative formula, 99.99% you are given the iterative formula. And you'll also be given the first starting value as x0 or x1 equal to. If they don't give, if it's between 3 and 4, start with x0 as 3.5. It is between 2.5 and 2.6, take x0 as 2.55. That means if no initial value is given, start the initial value at the middle point of the interval where the root lies. Then use the iterative formula. At each stage, write the answer to the accuracy required in the question. If it is 4 decimal place, write to 4. 4SF, write to 4SF. But when finding a value x2, use the complete calculator value of x1. When finding the value of x3, use the complete calculator value of x2 and so on. When do you stop? When two of the values you get, two successive values are identical. Then you stop there and say x equal to so much so is the root. Sometimes they say show that is correct. Then use your knowledge of GCSE boundary value. For example, if it is 1.41, 1.41 is 1.405 to 1.415. So find f of 1.405, original equation, and f of 1.415. Show there is a change in sign, then the root is between those two. Exactly, the root will be the midpoint, which is the mean value of 1.415 and 1.405. Yeah? So that's all you have to do in iteration. As I said, sometimes they tell you, you're given an iteration, you're asked to find the equation. How to do it? I'll show you in the next lesson with examples. So I'll see you in the next lesson, okay? Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.